Hello, this section is entitled Security, Create and Manage TLS Certificates for Cluster Components. So far we've been using the insecure HTTP protocol when we ran our pods and ultimately exposed it to our outside load balancer. Now our load balancer, our cluster or nodes are actually on a private subnet, so it's less of a problem. But there are circumstances where you need to use secure HTTPS between everything in your system. And so what we're going to do is look at how to do that. So what we're going to do is we're going to basically convert our services from HTTP to HTTPS. And it's a fairly lengthy process, so this video kind of will be fairly detailed. So the first thing to remember about all of this is that Kubernetes supplies its own certificate authority, right? And which means you can use Kubernetes to sign these certificates. We saw that when we were doing the user authentication using certificates. Now, the deal with that, however, is that if you're using a non-official root certificate authority that your browser does not understand or your OS doesn't understand, right? You need to then supply that CA, the certificate authority certificate, basically the public key for it, to your browser before it can then validate the server certificate that was created by it. Okay, so you can see that, for example, there's a we're going to use curl in this example, and there's an option called --CA cert that we'll use, where you basically have to pass the curl the certificate of the CA server before it can then, actually establish connection to an HTTPS endpoint. So the bottom line is we need to get the CA cert, the public key for the cluster, into a place where that curl command, which is going to be on a pod, right? We need to get it there. So one way of doing this is that we can first, so we're going to do this through a series of steps. Let me run this command real quick, and I'll explain what it is. So this is a command to output the view, config, right, and dump it out as a raw format that we're going to pluck basically off the certificate. There's a base64 code and version of the certificate, the CA certificate, in this output, and we're going to output it. We're going to run through a base64 decoder and dump it to a file. So if this all works right, we now have a CA cert. Okay, so that's the certificate for the certificate authority that we need to pass to, ultimately, to curl. Now, to get it there, what we're going to do is we're going to create a config map, and then we'll learn how to, okay, so let me just do it, and then I'll explain it. So cube control create config map. I'm going to call the config map CA, and it's from this file CA cert. And what that's going to do is creates basically a key value pair where the key is CA cert and the value is the certificate, right? And what we're going to do is we're going to be able to use this config map and then basically inject that certificate into our pods. We'll see that later. Okay, so that's so right now we should have get certificate. Config map. So there's our CA config map. Okay, so that's for that section. Okay, so we're going to change gears now. We're going to basically set up a server, right? And that server's domain name is going to be, just like you see here, example-dev default svc cluster local, right? And this is what's also new here. So I'm going to test this out. I actually did it earlier only with the fully qualified name. I'm also going to provide alternative names, meaning I want to make sure that this cert also works for example-dev.default and just example, actually -dev. This is a typo here. I need to fix that. I'll fix that later. So, so we're going to create a certificate that we can now give to our backend, our server or in our pod that that will validate those three names. Okay, so the way we're going to do this, there's a file called csr.cnf. Let's look at that real quick. VACICNF. Oops. CSR. So this is just a configuration file for OpenSSL, right? And basically this says, in this file, and I've got my values in here. You can change it to yours, but the first part of it's just kind of, scaffolding, right? And here I'm providing the certificates, the country, the state, the city, organization name. The common name is required, and that's basically the fully qualified name, right? And then I had to do some Googling, but there's a way to provide alternative names by adding this extension, and then you can provide the alternative names here. You got your example dev default, right? This. So in theory, I should be able to use any 3 of these names with the certificate, and we'll validate that. Hopefully that works. I haven't actually tested the 3, just the 1. Okay, so there's a command here, and you just basically Google the web until you figure this thing out. So this is an OpenSSL command to create. It'll do 2 things. Let me run it here and we'll see what it does. This will create both a key, so that's the new key part of it, and then it's going to create a CSR, which is a certificate signing request that we can now send to Kubernetes. So you'll see that there's 2 files now that are new. You got server.key and there's server.csr. So this is your private key, and then this is your certificate signing request. Okay, so that's ready. So the next thing is we need to get ready to send this to, and I think we did something like this earlier when we were doing the user business. But this command here, I'm going to paste it and we'll look at it. So basically this is taking this output here, right? And it's basically applying it to Kubernetes, right? And the reason why we're using this format is because we wanted to use this string, this shell interpolation, or whatever this is, shell expansion, right? This is basically going to cat the CSR and then base64 encode it and clean up the new lines and dump it right here. So that's why this format is convenient, because otherwise I have to do this in manual steps. Okay, so I got this out of the docs in terms of like the usages here. So this should create a new CSR that we can use to authenticate a server. Okay, and if I got this right, there should be this actually is kube, so kube control get a CSR, I believe it's called. Right, so there's my example dev. It's pending, right? Example dev default. So now I've got to approve it, and here's the command right here. Let's see what this command is. Let me paste it. I keep on saying control. Some people say cuddle, so I'll try to say cuddle. Kube cuddle certificate approve example dev default. So that should approve it, and I've got it approved. And then now I've got my certificate there. So now let's actually now get this certificate out of the system, and so we can use it. Well, we'll use it a couple steps here. So let me run the first command here, and I'll explain what it is. So first thing we need to do is essentially extract the. So this is getting the CSR, right, and it's out. It's using the output of. It's basically using this JSON path is extracting part of the output, and then sending it to, which is basically just getting into the certificate file. It's base64 decoding it, and it's writing it to the server cert. So now I have another file called server CRT, and there's my certificate. Looks like a certificate, right? Okay, so now I've got a certificate that, in theory, I now need to apply to my web servers, right? So that they can securely deliver. There's 3 domain names that they should be able to use. Okay, so so the next thing here is I want to make one quick check here. There's a command you can do is you can look at the output of what's in your certificate, right? That command is OpenSSL x05 blah 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 right here, right? Again, I just Googled that. Basically, you take the certificate in and you're outputting text, right? And the key thing I want to notice here, one thing is there is a expiration date here, essentially 1 year. So this certificate only will work for 1 year. So that means we're going to have a process, either manual or automated, to regularly update these certificates, which that's a different problem. I may eventually explore that, but right now it would be manual. Right? It basically recreate these certificates and reapply them to the servers on some cycle, right? And then I believe, let's see, that's the main thing I want to look at here. I'm trying to think if there's anything else terribly interested in here. No. Although I did notice, I was curious, I do see the CN here. I don't see in here the two other names, but it's not be output with this, so I'm not going to worry about it right now. But either way, well, I'll troubleshoot that later if those shorter names don't work. Okay, so that was that. Okay, so the next thing is we need a way, and let me just copy this and paste this. We haven't really talked about secrets yet, and there's more to it than what I'm going to say. But so so far we've been using config maps, and if you look at a config map, you can see all the data that's in it, right? There's nothing terribly secure about config maps. Now secrets, that's the name, are essentially the same thing as a config map to some degree. It's a key value pair, except for the values are all encrypted. Well, no, actually, let me rephrase it. They're not encrypted. They're encoded. And they're just basic. Here's the weird thing. They're just actually base 64 encoded. So they are somewhat protected, right? If you just look at it with your eyeballs, you can't read it. But you can easily, if you can copy and paste it, you can easily get out the secret, the actual value, if you have access to the encoded version of it. It does look like, we'll look at it later, but AWS has a mechanism to protect it even further, but that's something we'll cover later. We'll cover secrets. So just think of this as a key value pair, and this secret is, secrets actually have types, so they're a little bit more complicated, and this is a TLS type. So let me just create this real quick using the key and the cert, right? And if I just, for giggles, get secret, I'm guessing I'm not going to be able to get, so there's the secret there, the example dev. So if I say describe, right, wait, the wrong secret. Oh yeah, there it is right here, right? Here's that secret. And then if I try to, see if I try to get it. So get secret, example. I'm just trying to see if I can show you that it's encoded, but get example dev out YAML. Let's see what happens here. Right, so here you see the cert and the key are encoded files, but I mean, again, those are just, they're just base 64 encoded, so I can get that data back out if I really wanted to. So either way, so, and again, so the point here is there's just key value pairs. There's TLS cert and TLS key. Okay, so that's all I really wanted to cover there for now. So the point is we're going to use that secret to inject those keys into our servers. Okay, so now we're looking at the server configuration. Right, so one thing we're going to do is we're going to use Nginx as our server, right? And there's a file here. Let's look at it. Default.conf. So this entry right here, this is basically, I basically went to the Nginx website, right? And I read about how do I take the default configuration for Nginx has this entry in it where it's listing on port 80 and the server name is localhost, right? And then I said, well, how do I do a secure server? And basically, this is the section they gave me, right? You're listening on 443 SSL, you give it a server name, and you provide it the cert, right? And then some protocols and ciphers. So again, that was straight off of the Nginx website, right? So if I was to go here, it's basically what I followed right here, right? So I took the base configuration that was in the container, right? Copied it out and added this section essentially. So that, if you're wondering where that came from, that's where it came from. And everything else left the same. Okay. Now, still, just so you know, for reference, when I did this last time, I only considered the case of the fully qualified name. So we'll have to see if it works with the shorter names. And I'll have to add a notes afterwards if it doesn't work. Okay. So long story short, I created the configuration because I needed to override the configuration that's in Nginx, because the Nginx container by default doesn't do HTTPS. So I create a new configuration file, right? And then what we're going to do, let me copy and paste this. And then what I do is I've got this configuration file. So I'd use kubectl create another config map. I'm calling it example dev, and then from the file default.conf, right? So what this is going to do is create a config map, which is a key value pair, right? The key is the word default.conf, and the value is that file, right? So, and what we're going to do is that we're going to be able to use that to then inject into our server container to override the Nginx configuration. Okay, so, okay. So what we're going to do now is we're going to install everything right now and validate that something's actually working. So there's a lot of steps here. Let me look at what we're actually installing. So if you look under cert, under templates, I have three things. One is I have a pod. That's my Ubuntu test pod, right? Now you can see that I've done something here. There's a section here. And we haven't talked about storage and volumes and mounting, right? And we will. But the quick and dirty here is you can inject, remember, keep on talking about injecting in config maps. So in this camp, and we'll look at this more deeply again. Here I'm basically saying, hey, this pod is going to use a config map named CA, and I want to reference it in the containers as CA cert, and then at the container level, I basically mount the data that's in that config map into a folder called /cert, and then and this CA cert refers back to this. So long story short, by doing this, I should have a file in this Ubuntu container under /cert named, I believe it's ca.cert, and then I'll be able to use that when I want to use my curl command to access it, because that's the CA cert. Okay, so that's one part of this. Now on the server side, I had to do something similar. So my that would be under my deployment, right? I had to create two volumes. One is I needed to inject those certificates. So that's coming from a secret, okay? And then I needed to inject in the configuration file. And then you can see I did it that way, right? So this is and then I'm using them and mounting them. And one is the SSLs into this, etc., Nginx SSL. And then I'm specifically taking configuration and overwriting the config.d or confd. Okay. So again, we'll talk about specifically about this, but if you squint at this, essentially what I'm doing is I'm telling my server where its certs are, and two, what its configuration file is. Okay. With all that in place, I can deploy this thing. Helm, install, and we'll do some poking around. Okay, so if this works right, this should install. Okay. Right, okay, I know what we're doing. So I should do kube control get all. Okay, so I've got my deployment, my replica set, and all my pods for my backends, right? And then I've got my Ubuntu we'll talk about this load balancer in a bit. Yeah, let's look at the load balancer for a second. I jumped ahead of myself. I forgot it. The load balancer, I wanted to also illustrate this whole end-to-end HTTPS by using HTTPS to communicate out to the load balancer. So here I've got a load balancer set up like we did last video or recent video. And I can see it's on port 443 and the target port's implied to be 443. So I'm exposing it, the load balancer's on HTTPS, and it's going to be using HTTPS to contact the back end. And you can see that I've also changed it to HTTPS and the back-end protocol. And of course, I still have my cert. This cert is my outside cert for my outside load balancer, right? Just like I had before. So this will create a load balancer, and the load balancer will use HTTPS to communicate to the pods, essentially, not HTTP. Okay, so now that I've seen that, that'll make sense of what this load balancer is. For now, I want to do is look at it from the internal side. What I want to do is I want to use this pod right here, and I'm going to connect securely to this internal service on this IP address right here. So let me copy this IP address. Well, actually, I don't need IP addresses. Everything's DNS, so that's fine. So let's do this. I'm going to do kubectl exec example dev. I'm basically logging into the pod. Okay, so I'm on the pod because I need curl, so I need to do apt get update apt get install curl. Okay, so now I have curl. Let me just copy and paste this, and then we'll talk about what this first check I'm doing. Okay, so the first command here is I'm running curl, right? But this -k is basically the insecure mode. So it's going to use HTTPS, but it's not going to check that this DNS name is part of the certificate it gets back. So it's just and you can see clearly I'm getting my Nginx stuff. So that's first good sign. So at least my HTTPS, the server is running under HTTPS, and I can, securely get the data. It's just not the host name, the domain name is not validated, right? The next command, now this is going to be the moment of truth. Well, this is the first moment of truth. So here, well, let me do one thing. ls/cert. Okay, there's my cert, right? That was injected using that volume. Now let's actually use that. So I'm basically passing the cert to curl, and I'm trying to access that, and that worked, right? Now the moment of truth really, and I have about 50-50 chance of this working. The question is, does that work? No. Yeah. Does not match the target host name. Yeah, this might be subject name. Yeah, I'm going to have to research this more. It looks like the way I created that certificate is still not valid for the shorter names, right? It's only valid for the long one. So I'm going to go research this outside of this video and put an addendum in the notes. Okay, so what I did originally does work. I have a valid certificate, but it's only valid for the fully qualified name. Okay, so leave that alone for the moment. Okay, so that's good. Okay, so now load balancer. Let's look at the load balancer here real quick. Console. Okay, let me log in. And go to EC2. I'm going to go to my load balancers. I'll kind of gut check it there. So there's my load balancer. It's in service, okay? And then in terms of how it's communicating, you can look at listeners. I can see that the load balancer is exposed as HTTPS, but the instance is also exposed as HTTPS on port 31793. And this certificate is for this outsider here, right? So should be working, and then the last step of this exercise would be go to Route 53. I need to map a name to this. So let's see, TOS.com. I probably have an old name floating around here, right? Here's example dev. So let me delete that one. So my certificate I have is a wildcard cert. So I can just do, I don't know, I'll just do something different this time. silly.todoers.com, and then I'm using an alias that's pointing to this load balancer. Create. Okay, now I have a silly.todoers.com, and then I should be able to go to my browser, todoers.us.com. Of course, it probably doesn't work. I have a lot of problems with DNS for some reason. Sometimes this DNS doesn't get propagated. Like right now, I'm not getting DNS working. So hang on a second. Let me do a little troubleshooting on screen. So I'm back on my machine now. NS lookup silly.todoers.us.com. Okay, that's now resolved. So if I do curl HTTPS silly.todoers.us.com. Okay, that worked. So I know the server's working. Now the question is my browser working? Oh, it is working. Maybe it was just time lag. Okay, so now silly.todoers.com. I've got HTTPS from my browser to the load balancer, and then HTTPS from the load balancer basically into the cluster and onto the pod. So I have end-to-end HTTPS in this example. I do have a little bit more in the video here. And again, I'll look at this short name thing after this. So one thing, this is a sidebar. So we're talking about certificates, right? So the first time we ran into these certificates is when we did user authentication, when we using client, basically client certificates. We just saw another example here of certificates being used to secure our workloads, right? With server certificates, right? Under the hood, Kubernetes actually uses certificates for lots of things, right? So just a couple examples. There's a document that talks about all of them, but for example, the kubelet needs to talk to the API server. So there's a client certificate so that it's basically it's authentication for the kubelet to talk to the API server, right? There's also a server certificate on the API server endpoint to validate itself, right? And there's other ones, right? And this uses the same CA as we've been using, and that CA has a 1-year renewal, so it expires after 1 year. And so the question is, well, what happens when all these other under the hood certificates expire? Is there a problem? And the answer is there would be. The good news is it looks like, I'm reading the docs, so whenever you upgrade your control plane, right? Basically when you upgrade your control plane, all of your certificates get upgraded in the process. And apparently this best practice, according to docs here, that you should be upgrading your control plane on a regular basis, which is at least once a year, right? In which case, these certificates will always be managed for you, and you never have to worry about it. And that, you don't have to worry about having to manually upgrade your certificates or renew your certificates. If you install separately, if you did use kubeadm to install your cluster, like we did in an earlier example, right? There's a command called kubeadm alpha certs renew, which will go through and upgrade all your certificates for you or renew all of them for you, right? And you can do that anytime. Now, in the case of EKS, we didn't use kubeadm, so I was trying to Google about how I'm supposed to update these certs, and it looks like the only way I can think to do this is make sure your cluster is up to date, or Amazon is somehow taking care of it for you. I'm not sure which, but I think the best bet right now is you should follow the general guidance of regularly keeping your cluster up to date just for security patches. Okay, so I think that's it. Again, I will deal with this problem of the shorter names, and I'll put an addendum at the top of this, right about here. Thank you.